we are moving into the last form of writing a equation for a line. There's three ways to write it. Slope, intercept, that's what we were introduced at first. Then we were introduced to point slope. And the last way we can write an equation of a line is what's known as standard form. And standard form is below, and it's said as ax plus by equals c. So the properties of standard form, x and y are on the left side. X and y are on the left. They're together on the left. X is always before y. It has to be. If it's second, you have to apply the commutative property of addition, and you have to flip it to make sure that it comes before y. It's in alphabetical order. Y does not come before x. And you want to make sure that there are never any fractions. And that's going to be more tomorrow's lesson. But if we get fractions, it's not in proper standard form. Proper standard form is ax plus by equals c such that a, b, and c are integers. Integers is not a fraction. Okay, so that's properties of standard form. And then the next page, the purpose of standard form. This is the why do I care. Why do I care about standard form? Because you can graph much faster. If you feel like standard form is ridiculous, you already know slope intercept and you know how to do point slope. Standard form is definitely very useful at certain times. Standard form takes into consideration intercepts, not just y-intercepts. It tells you x-intercepts as well. So I want you to be able to identify intercepts. So I want you to make a dot where this line crosses both axes. So this line crosses the x-axis at 1, 2, 3, 4, approximately -5. I intercepted the x-axis at -5. And it looks like I intercepted the y-axis at 1, 2, approximately 4. My eyes are having a hard time visualizing that. Right around there, though. I think you can get the gist of it. That when I intercept, that means that the line crosses the x-axis. And when I intercept the y-axis, the line crosses the y-axis, right? Intercept means cross. Let's analyze some properties of intercepts. So make a little baby coordinate plane. And then make a line that goes through it. I don't care what your line looks like. I'm just going to make one. And I want us to analyze what are some characteristics of intercepts. So looking at my x-intercept, remember the x-axis is the horizontal axis. Looking at my x-intercept, what is my y value? What is y? How far up am I or how far down am I?
Y is up.
Is it anything? Is y anything right now? X is negative something. But did I go up or down? I did not go up or down. At the x-intercept, y is 0. That will always, and that's the key. That's what's going to help us quickly be able to graph things. That we know, hey, at one intercept, the other thing is nothing. Okay? Let's look at my y-intercept. So I went up. Did I go left or right anywhere? No. So what is my x value at the y-intercept? X is 0. The purpose of this, for you to be able to understand, is at the intercepts, the other variable cancels out. Right? Because if y is 0, it's canceled. It's not even there. It's non-existent at the x-intercept. At the y-intercept, there's no x. X is nothing. It just totally canceled out. It's only y at the y-intercept. At the x-intercept, it's only x. Okay. You have to have an understanding of this for being able to apply it to quickly graph. And that's what I want you to be able to do today. I want you to be able to identify standard form. I want you to be able to, when you're given standard form, you need to tell me what the x and y intercepts are. And here's how you do it. Whoopsie. When you find the intercept, knowing that at one intercept the other variable cancels out, we want to cover up the opposite variable and solve. So here we get to do algebra. I love algebra. And then that's it. So I create a t-chart is what I do. My x-int and my y-int. I know that every line is going to cross through my x-axis and it's going to cross through my y-axis. So I'll show you how to do this. So at my x-intercept, y cancels, right? At my x-intercept, y is nothing. So I'm going to cancel out my y, and what do I have left? 3x equals 24. X is 8. That means that this graph crosses the x-axis at 8. At my y-intercept, and maybe if you need help visualizing because this is such a new concept, at my y-intercept, I'm going to have no x. X doesn't go anywhere. So your x will cancel. So get rid of it. There we go. And what do I have left? I have 4y equals 24. Y is 6. You might be like, this is ridiculous. It's not ridiculous because you can quickly graph a line. I would cross my x-axis at 8. I would cross my y-axis at 6. I can connect my line without doing slope, without doing point slope or anything like that. It's very, very, very effective and fast. Okay, make sure you plus a negative. You can't let any negatives hide from you. And then I'm going to remember, at my x-intercept on this line, I'm not going up or down. So my y cancels. So that means I can just cancel out my y. And I get negative 2x equals 20. X is negative 10. You're not going to have to do intense algebra with this, but you definitely have to do some algebra. At my y-intercept, along this line, I don't have any x's. I don't go left or right. So my x cancels. You don't have to write that. I just want you to understand, while I'm just teaching this to you, that the other variable cancels out. So at the y, there's only y. And I'm left with negative 4y equals 20. Y is a positive 5. And look what I can do. I'll show you what I can do. I'm going to make a rough sketch of this graph. My x would intercept at negative 10, right around there approximately. My y would intercept at 5, right around here, and my graph would look like this. It'd be very, very fast to graph it. Okay, I want you to try the next two. Okay, so it was brought to my attention that I forgot when I looked at this y-intercept of the last one that we did. When I divide by negative 4, my y-intercept should actually be negative 5. Oopsie. Moving on to the next one. I want to find the intercepts. This is in standard form because the x and y are on the left-hand side, and x is before y. Finding my x-intercept, I know that my y cancels at my x-intercept. So now I'm taking into consideration that you just know that. I'm not going to write the cancels. You're welcome to if that's going to help you. So on my x-intercept, I get rid of my y. And my x equals 9. My y-intercept, the other variable cancels. So notice that x cancel the y. Y, I'm going to cancel the x. So my y-intercept, I have 3y equals 9. Y is 3. And I would quickly be able to graph this because x would intercept at approximately 9, y would intercept at 3, and I would be able to quickly graph that line just using the intercepts. Much faster than getting y alone in slope-intercept form. This next one, I hope you plussed a negative and made the 1 come out. And then I like to just kind of separate my two intercepts. You definitely don't have to. X means that there's no y. Y cancels out. So I'm going to get rid of that y term. And I get 5x equals 9. And it's okay that it doesn't go in evenly. X is 9 over 5. Okay, 5 goes into 9 one time. 4 remains, 5 is the denominator, so 1.8 approximately. You could use your calculator, of course, for that. My y-intercept, I need to get rid of my x. So I have negative 1y equals 9. Get rid of that negative 1 by dividing, and I get y equals negative 9. So you can still quickly graph this. It's a rough estimate because I am not going to calculate officially 0.8. There's no way I'm going to do that. And I get approximately 1.8, negative 9, and my graph would look something like that. So now that I've been showing you why I do it with all these graphings, let's formally learn how you graph in standard form. And last target of today. Today you have to identify forms, you have to identify intercepts, and then you have to graph using standard form. You can get y alone, but please do not. It's going to be a lot harder for you. Really apply the intercept strategy. So the first thing you do is find the intercepts. Plot and, I don't know what I wanted to say there, connect. Plot and connect, probably. Sounds good. Find the intercepts, it's plural, there's 2 of them. And then you plot and connect. Okay, so I want to graph this line using intercepts. Well, there's 2 intercepts. I have an x-intercept and I have a y-intercept. Did you know that? 2 axes, 2 intercepts. On my x-intercept, here I'm going to plus a negative so I don't mess that up. On my x-intercept, my y cancels out, so I get rid of it. So I have x equals negative 2. At my y-intercept, my x cancels out. So I'm going to get rid of, whoopsie, okay. So I'm going to get rid of my x. Oh no. Can't do it. Okay, so if I get rid of my x term, I have negative 2y equals negative 2. Y is a positive 1. Negative 2 divided by negative 2, positive 1. And now I can quickly graph. X, it crosses the x-axis at negative 2. It crosses the y-axis at 1. And you connect it. And there is your line. Much easier than getting y by itself. Is that the only example I have for you?
Yeah.
Okay.